Diocles of Carystus, Illuminating Ancient Greek Mathematics. Diocles of Carystus, a luminary in ancient Greek mathematics, was a profound geometer and mathematician renowned for his groundbreaking discoveries in the subdivision of geometry. His enduring legacy is encapsulated in the mathematical realm through the geometry curve, now known as the cissoid of Diocles. Born in the city of Carystus on the island of Euboea in the latter half of the 4th century BCE, Diocles' life unfolded during a pivotal period in Greek intellectual history. His significant contributions, particularly in the field of geometry, have earned him a distinguished place among ancient mathematicians, despite the loss of much of his original work. Fragments and references in later mathematical texts provide valuable insights into the innovative mind of Diocles. Biographical sketch. Diocles' life is shrouded in historical obscurity, with details scarce and derived from fragments and references in later mathematical texts. Born around 240 BCE in Carystus, situated on the southern coast of Euboea, Diocles lived in an era influenced by intellectual giants such as Euclid and Archimedes. Beyond his birthplace and approximate birth year, the details of Diocles' life remain elusive. However, his mathematical contributions, particularly in conic sections, illuminate his legacy. Mathematical contributions, conic sections. Diocles' primary claim to mathematical fame lies in his pioneering work on conic sections, a branch of geometry exploring curves formed by the intersection of a plane and a cone. Although his treatise on burning mirrors, or the burning mirrors, is lost, references in later texts reveal glimpses of his groundbreaking ideas. His focus was on the curves formed by sectioning a cone with a plane parallel to its base, specifically on a conic section known as the cissoid. The cissoid is generated by the intersection of a circular cone with a line originating from a point on the cone's diameter and intersecting the opposite side of the cone. Diocles utilized the cissoid in the context of burning mirrors, addressing a mathematical problem related to focusing sunlight using curved mirrors for heat or fire production. Although his original text is lost, later mathematicians, including Pappus of Alexandria, referenced Diocles' work on conic sections in their own writings. Diocles' curve, the cissoid. The cissoid curve investigated by Diocles is defined both geometrically and algebraically. Geometrically, it represents the locus of points traced by a line segment attached to a fixed point on a circle as the circle rolls along another circle of equal size. Algebraically, if the coordinates of the fixed point are a0 and the equation of the circle is x squared plus y squared equals sine a squared, then the cissoid's equation can be expressed as y squared equals sine x cubed, 2ax. This curve's intriguing properties showcase not only Diocles' geometric intuition, but also his mathematical ingenuity in addressing practical problems related to mirrors and optics. Application to burning mirrors. Diocles' mathematical investigations into the cissoid had practical implications, especially in designing mirrors to focus sunlight for maximum heating effect. The challenge was to construct mirrors that could concentrate sunlight, and Diocles' work demonstrated a sophisticated understanding of conic sections and their applications. The cissoid's specific shape allowed for the construction of mirrors capable of concentrating sunlight effectively. Diocles' exploration of the burning mirrors problem represents an early instance of the intersection between theoretical mathematics and practical applications. Legacy and influence. Diocles' legacy is embedded in the foundations of geometry, particularly in the study of conic sections. His pioneering work on the cissoid and its application to burning mirrors showcased the utility of mathematics in solving real-world problems. Although his original treatise is lost, the echoes of his ideas reverberate through the works of later mathematicians. The cissoid continued to captivate mathematicians' imaginations, finding applications in diverse mathematical areas. The curve's unique properties led to further investigations, making it a subject of study for mathematicians in subsequent centuries. Diocles' contributions to geometry and conic sections also influenced the development of mathematical thought. Later mathematicians, including Apollonius of Perga and Pappus of Alexandria, acknowledged and built upon Diocles' ideas in their own works. In the broader context of mathematical history, Diocles represents a link in the chain of thinkers advancing the study of geometry and conic sections. His work contributed to the growing body of mathematical knowledge, eventually culminating in the masterpieces of mathematicians like Euclid and Archimedes. Conclusion. Diocles of Carystus emerges as a significant figure in the landscape of ancient Greek mathematics. His pioneering work on conic sections, particularly the cissoid, and its application to burning mirrors, highlight the practical applications of mathematical concepts. While his original treatise is lost, the impact of his ideas endures through references and influences on later mathematicians. In the evolving narrative of ancient Greek mathematics, Diocles stands as a testament to the intellectual curiosity and innovative spirit of the era. His exploration of conic sections not only contributed to the theoretical foundation of geometry, but also showcased the utility of mathematics in solving practical problems. In the grand tapestry of mathematical history, Diocles' legacy remains woven into the fabric of geometric inquiry and the intersection of theoretical mathematics with real-world applications.